I'm Logan Cerkovnic from Thumper AI, and today I'd like to tell you about how you can run vLLM on Akash. Now, this is a part of a partnership with Thumper and Akash, and we're doing a series of blog posts about some really cool things you can do with AI on Akash. And so today I'm here to talk about vLLM. This is going to be a tutorial on how you can do vLLM on Akash for everything from replacing like Chat GPT with a chat user interface, all the way through to how do you use this with Langchain or Crew or some of these other agent tools that use an OpenAI compatible API interface. And so that's really exciting. This tutorial is going to be mostly geared at a little bit more of a technical audience. So if you're not as technical, that's okay. I'm going to try to explain things a little bit, but it might be a little challenging to understand some of these ideas. But hopefully you can follow along the video if you are somebody who maybe isn't as familiar with some of these things and be able to use vLLM on your own. So what really inspired me for today's video is I kept seeing a lot of developers who love Ollama. Now, the Llama 2 ecosystem, Llama CPP, Aphrodite. There's some of these really great tools that are built, amazing open source, LLM server tools that allow you to use open source LLMs locally that are kind of geared at like, how do I give a single user running a LLM locally the best experience possible? And what I've seen is that there's a lot of developers today who are saying like, gosh, I love this like local experience so much. I just want to find a way to like bring that, or can I build on that for my users for an application that's supposed to scale a lot more, or can I use that for like my entire office, or maybe like team for if I have a team of developers who's using different LLM tools to generate code, for example. And so, and one of the things I find myself, continuing to like tell people is like, hey, Ollama is great for one person, but what Ollama doesn't do well is high throughput, multiple requests at the same time, multiple concurrent users all submitting their requests at the same time. That it wasn't meant to do that, and so. Instead, I would recommend that people go to kind of either vLLM, which we'll talk about today, or TGI, which is another good tool. I think vLLM has an edge there in terms of performance. So I'm just going to cover vLLM today, but maybe I'll do an example of how to use TGI in the future. So first off, I'd like to just kind of say is like, why Akash? Well, Akash is really cool because Akash is some of the cheapest GPUs on marketplaces that I have found. You can get today like GPUs for A100s for like $1.40, or A100s 80 gigabytes for $1.40, or H100s for about $2 an hour. So that $140, $2 an hour, that's a really huge improvement over AWS, which a lot of times won't even give a lot of people A100s or let alone H100s. And a lot of times the H100s, I believe, like the standard pricing is sometimes comes out to being like close to like $20 an hour, depending on how you calculate that. And so that's really kind of disappointing, is like, not only is there like it was way more, but there's also a lot of like gatekeeping, which is bad for startups, smaller development teams, people who are kind of like trying to move quickly. And previously Akash and Thumper, we trained the AT1 our text to image foundation model on Akash to kind of show people, yes, you can train on Akash. And Akash is special because it's kind of like this Airbnb for data centers, where anyone can go build a server and lease out the GPUs on that server for other people to rent and buy. And that means you're going to get much better prices in this sort of open marketplace than you would in other places. And so Akash is really fantastic. But one of the challenges with Akash is that the deployment YAML is a little bit different. And so today, we have all of this code that we're merging into the community repo that kind of shows you all the deployment YAMLs and what you need to do to be able to run vLLM on Akash. And so that's great. So first, so there's also, I was also going to bring out, there's also an accompanying blog post that will be both on like the Akash blog page, as well as this also here in the README. And so on this awesome, this is our fork of the awesome Akash repo. The original repo is awesome dash or is Akash dash network instead of Thumper AI. It will be merged in soon. So if you go here, and this is kind of like the README of this vLLM folder of the awesome Akash repo, what you can see here is that, so vLLM came onto the scene, kind of came out, I believe, last year around June with their paper or preprint. And what was the main change that vLLM made from other prior sorts of LLM servers was kind of saying that, like, we're not necessarily using, memory usage as efficiently as we could be. And so in a lot of these examples, and so if we can swap out our normal transformer attention heads for the paged attention implementation, we can get about double the throughput. And in some cases, we can even get more, I think, depending on the circumstances. And that was like at that point in time. There are some other like state-of-the-art advances that have been added to vLLM. I believe there's a couple of PRs that have been merged in recently for like speculative decoding approaches, which boost performance even more. And so it's definitely something to keep kind of an eye on. And I think that like the communities, I think the strongest kind of community for distributed vLLM, like LLM servers, is around like maybe vLLM and I think like TGI. So for people who want kind of an open source server implement, high throughput server implementation for open source LLMs, those are kind of like the two projects that like I said kind of previously, like that I really recommend. And so there's a lot of like really positive. So you get really high throughput. What are that's kind of like the biggest pros, right? The con of it is that, like, the cons are kind of, if you have a model that no one else has used before, an LLM model, not like a fine tune, but like, some radically different transformer architecture or something, or for some reason, like your model isn't supported in kind of like some of the previous APIs that are used, sometimes you will have to go through and swap out in kind of the PyTorch model file, go through and swap out the attention for this paged attention implementation. And that can take a little bit of time. The people on you can create an issue on the vLLM GitHub page, and there's normally someone who will help you. There's also a list of all the models that are previously supported there. Generally, support tends to happen pretty quickly. But, so that is one drawback, is we do have to swap out the attention for paged attention. It's already been done for the vast majority of models you would be interested in, happens pretty quickly. For the ones that aren't, for the other drawback is that for people who are in the kind of camp of who love their GGEF files, or which are very popular quantization formats that are used in like Olama, there's not support for that today in vLLM, which means you'll have to use a different quantization format. I usually recommend people use the AWQ quantization format, and the and it also supports GW, GPTQ. And the reason why vLLM didn't support GGEF is kind of that they felt the authors, or some of the contributors and authors of the original paper, I believe, felt that some of the other file formats were a little bit more challenging, to support. But it's been on it wouldn't surprise me if it eventually does get added. I think the positive thing about it not supporting GGEF is you don't necessarily have to, if you're not as familiar with these different quantization formats in GGEF, where there's about like 7 or 6 different levels of quantization, you can kind of just go out and find an AWQ version of the model you're interested on Hugging Face, and use that instead, and that will work really well. I mean, it's kind of a good kind of trade-off, as opposed to, what we see with a lot of the GGEF formats is after we go below kind of the 4-bit Q4 quantization, there's usually a pretty steep drop-off in performance. And so rather than having to kind of like think about that you can kind of just focus on like, let's use AWQ with vLLM, for these high throughput servers that we want to use. And so that's a really, those are kind of the two drawbacks. but again, like I think there's a lot of benefits, and I think it's clear to me that like a lot of the community support there's a lot of community for support for different other features that have been merged into vLLM. So yeah, so I think we've kind of talked a little bit, and then I guess like maybe the last kind of important thing to mention is that typically when you run a vLLM server, it's only going to support one model and not really going to support changing that model. And for people who are very used to a llama where you can swap the models back and forth and just wait for it to reload, that might be a little bit frustrating for some of those people. And to those people, I would also, mention that like the reason why you can't have that on vLLM is because if you have multiple people on like an Llama server and they just change the models, like a bunch of fine-tuned models back and forth, they prevent anyone else from using that particular GPU instance sometimes as the models constantly like reloaded and unloaded. And so when people do build and try to build a service on a Llama, what we see a lot of times is that people end up giving every user gets their own GPU instead of like 20 users getting a GPU on vLLM, on vLLM, and or we see this like we kind of have to spin up like almost like an Llama instance sometimes for every user. Is what sometimes ends up happening to try to get around some of those drawbacks. But yeah, so that's some of the different. That's kind of like vLLM at a high level. So today so today we're going to jump into now a tutorial of how you can run vLLM on your own, because that's what I think most people are interested in. We've kind of given a little bit of an overview. Obviously, go read the paper if you're interested. There's a lot more there's a much better discussion there. And in terms of benchmarking specifically today, I believe it's the performance bench tool is from Anyscale for doing some of the benchmarking that you will need to do if you're interested in getting kind of like a really like honing in on exactly like how many users and trying to do cost analysis. Like there's some better tools today for doing that. I believe it's MLPerf is the benchmarking tool for that. But great. So let's get into our deployments here. And so what we have here, if we look at this repo, is we have a couple of different deployments. So deployments and then are these YAML files. The first one that you'll notice there's like an initial. We have like a Python notebook here that shows how to use the OpenAI. How to connect using Langchain or Crew to connect to a vLLM server that's hosted on Akash. We have this Crew notebook, Jupyter notebook, so an example of how you would run a Jupyter notebook that connects to the vLLM instance. We have a vLLM deployment without a user interface. That's just literally kind of like a plain user interface example, like just vLLM alone. And then we have Open Web UI. Open Web UI is really cool because Open Web UI, I believe it was formerly the Llama Web UI, but Open Web UI is kind of one of the few open source LLM user interfaces that's kind of geared at trying to help multiple users use the same service. Because again, what starts to happen is like, okay, we put everybody on like a single user application, then all the chat history is like shared between everybody in like a work environment, for example, which is not super exciting. Like, I think there's some concerns with people doing that. And so instead, I think this is a much better alternative. So you've seen several ones here. I've got the Wizard LM2 7 billion parameter model. Why did I choose Wizard 7 billion parameter model instead of Llama 3? Well, specifically, the Wizard LM2 model, 7 billion parameter model, it was a huge jump when it came out. I still favor it, and sometimes over the Llama 3 8 billion parameter model. And so so we're going to run with this one today. And it's set up here. As you can see, we have kind of our Akash deployment. We define our services vLLM UI. I'm going to note that there is there are some fields that you would want to configure if you were doing this for your work or for a team of people. And like one of them is you probably want to change out this Hugging Face token, because there's some models that do require you to sign in and kind of have like agreed that you've used the terms of service and stuff. So you will need to change this environment variable here, this field, and then this password field as well. Right now, we've just set it to my password. You should definitely, if you're like wanting to create a team, like replace this with a somewhat random or much longer password that people on your team can kind of use. The same way you use kind of like an API token with OpenAI ChatGPT for different purposes. But again, this doesn't use any OpenAI at all. It's just the OpenAI kind of like API compatible standard. So it's plug and play with a lot of other different applications. And we have our bidding here, and we can see so cool. So this is our deployment. We're going to go here. We're going to copy, Control C, copy that, and we're going to paste that into the Akash console. So if you go to the Akash console, the address is console.akash.network. If you go there, you will go here, and then you will see kind of like if you have any deployments, there's a deploy button and a wallet. So before we go through the tutorial, you will need to go through and make sure that you have added that you make sure that you have some tokens, some AKT tokens, or some of the stable payment options. The stable payment options are described kind of in the Akash docs. So it's Akash Network /docs, I believe. Then there's some more descriptions on how you can pay also. But if you're like a normal business who wants to pay through ECH or credit card, you can also reach out to Overclock Labs, which is kind of like the main company that helps work with the Akash network and develops it and kind of manages a lot of the things with it. And so you can either reach out to Overclock Labs or you can reach out to me, and I can help make sure that you have, if you're a business and you don't want to mess with anything crypto and you just want to do ECH and credit card payments, that can absolutely happen. And there's actually a general purpose feature that some of the developers with Akash and Overclock Labs are working on. So there will be the option to pay with credit card for a broader audience soon. But again, we hope that's not something that like prevents anyone from using this. But yeah, but you'll need to create an Akash wallet, and then usually install a plugin for that. I use the Kepler wallet and there's a wallet extension on Chrome, and there's also a wallet extension on Firefox, which it wasn't for a while, but now there is. So you can use the Kepler wallet on Firefox and on Chrome. That's really, so you'll get that. You want to make sure you have some money there. If you're just kind of messing around with it, like you can easily just put like a couple $100 maybe is what I like to use. But I mean, it depends on kind of like your use pattern here. And we'll talk a little bit about, as we go through this, kind of like how much you would expect to, you can look at and kind of get an estimate of how much things cost. How much the different server leases do cost. But if you're just doing a lot of dev purposes, anywhere from like, you can probably do some early dev and just kind of like stuff for like maybe $50 to $100, and that is a good amount. If you're interested in getting the Akash token, I believe it's on Kraken, and there's also the other option is to go to osmosis.zone. And buy, and if you buy either a Cosmos token or some of the other tokens that are on osmosis.zone, you can kind of swap it for the AKT token to your wallet. So, but which will be important for when you go to deploy here. So we'll be interested in deploying. So we'll click on deploy. So that's great. And so we have a couple of options. And you could do upload your SDL if you have the SDL locally. What I like to do a lot of times is click on this hello world example. We're going to call it vLLM UI tutorial. And then I'm going to copy and paste the deployment that we copied from, and we go, okay, this looks good. And before we proceed to the next phase, what's a good thing to kind of do at this place is look at this Hugging Face repo. And we want to do a double check and say, like, am I pretty sure that this will fit on my card? Right? So I'm like, I'm not really sure if this is going to fit on my GPU. So I'm going to go here and go to Hugging Face, and we go, okay, great, cool. So we got this. We got a version of the model here. and we go, okay, we're going to click files and versions. And what I'm really looking here to check at a high level is just to say, like, how big is this? So this overall model file stuff that gets cloned, like, it looks like it's about 4 gigabytes in RAM here with the quantization. Um, that's definitely something that can fit on the consumer grade GPUs like the 4090s. And so we're going to say, like, okay, so I can probably run this on anything that has, like, maybe 4.2, or I'd like to say, like, if that file, we want that to be like only consume 90%, no more than 90% of the total VRAM or graphics card memory that we want. And so the reason why we're going to check here is we're going to go, okay, create deployment. We have to make a deposit for the lease. And so this is kind of like, we can add to this as we go. So you don't feel like you have to put like the entire amount here. I'm just going to put like 10 AKT, which is about like $40 here, and then go, okay. And this is how much is like going to be on the lease initially. And then we have to confirm the transaction. This is a gas fee, which is like, for those of you who may not be super crypto savvy, it pretty much pays for the servers that verify the sort of lease and like financial transactions. And so it's usually, like a penny, maybe 2 pennies, but we'll click OK, which is fine. So we go, okay, opening, we'll wait for this, and then it'll be transacted, and then we'll start getting lead bids from different providers on Akash. So again, Akash is this kind of decentralized network, and we're going to get bids from all sorts of data center providers. And if and so we look at this GPU column here for what we're doing today. This GPU column is very, very important, because depending on the GPU, because there's obviously a big price difference, we can see this H100 here for $1,100 a month, our A100 here. We have some A100s as well, and then we also have the 4090. So eventually, like, it's a lot more expensive. Depending on, I mean, it's much cheaper than AWS, but even amongst like the right graphics cards, like if you can run something on a cheaper graphics card or a consumer graphics card, you probably should, but at the same time, if you have like some really, hundreds of users or thousands of users or something like that on your service, there is a scaling effect where, as you move probably to some of these other, you may get some economies of scale with the higher end graphics card. So it's just going to depend a little bit on your application. But today, for what we're doing, a 4090 is absolutely great. And so we're going to click here, 436, 64, 436.24 a month. Not bad. We're going to go accept bid. Okay. So now what's happened is we're waiting for the bid. We've clicked accept. So the application is deploying here. And now we're going to get to kind of like this deployment stage. And that kind of shows us a couple of interesting things along these tabs. The first tab here is this tab shows kind of our leases in terms of like a high level summary, and gives us a link to where the URL for the service is going to be located. In our deployment YAML, we're only exposing one port, and we're exposing that globally, and that's for the chat user interface. And so we're going to click this when this is up and ready, and we should be able to go to it. But before we do, I am going to go back to this events tab. And why is this events tab important? Because we can see, so if we're going to troubleshoot, when things sometimes don't work out with our leases, like this shows a 1 available, total ready, so if this is 1-1, this is 1-1, or however many we wanted, but like this looks like it's successfully deployed. If this was a 0 or this was a 0, something didn't work out. And as well as, if we go to this events page, we should see, these logs that say, created, container, started container. We'll see some errors sometimes if we can't pull, if the Docker container was wrong, or, we would see this, or if the Docker container is having a hard time starting. So we are going to download the model weights if we see this, we see we're actually downloading the model weights first. At start. And so if that fails, we'll actually see that here, and we'll also see that in the logs button. And so if we're the way, we've listed in the blog a number of ways and steps for troubleshooting. So this is kind of the events tab, then the log tab as well, and you can filter by this. And so we can see here, as it was starting up, we did download all the files for the Wizard LM2 7 billion parameter AWQ. And it looks like it started, and we're getting some metrics on like the performance, which isn't, we're not using the service yet. So this is like a really good sign. So it looks like everything is here. If something didn't go right, it would usually say, you'd find out kind of in this logs tab or this events tab. Great. And if you, and you can also, if if you're a developer and kind of familiar with like Linux shell commands, you have this shell. You usually want to do bash first to make it like a bash one, and you can see kind of like what's inside the container and see like, if there's like some configuration file maybe, or something that is not quite working, you can use that to diagnose problems as well. So that's great. So now let's go check out Open Web UI. Now, so we do get this, so why do we have this? And so what we have here is this HTTPS. There's a default Akash HTTPS certificate from the provider. And so in order to, if you did want to host this for your company, you would want to go and create go into a DNS provider like Cloudflare and create and use the DNS tool to kind of do to get a good HTTPS certificate and point that at this address up here up top. I think doing that is a little bit outside the scope of what we want to do today, but that's why we're getting that error, because we have kind of a automated certificate that hasn't been created for the right URL. And so to get one for your URL, you will need to create, I believe, like an A record and point it at this HTTP address for your site. And so, so you do that. So now we get to Open Web UI. You go, oh, and again, it's going to give you this warning about because of the HTTPS issue. And so you're going to go to sign up, and no, I definitely check this out here, because this is I think this is important. Like when you're signing up here, you're not actually, you're creating a user account. You're not really signing up. So we say Logan, we say email, Logan at Thumper AI. And we'll create like a password, like I love Akash. Cool. Right. We'll do something like that. We'll create an account, and we'll go not now, because we could save that if we wanted to. But again, so this isn't going to go connect to some external service. It's literally just on this page. And so the main thing is that this is cool because now users actually have privacy, which is fantastic, because you can have multiple people log in, and one person at your company can't see everybody else's queries, and people can feel a little bit more comfortable for multiple user setup. So cool. So that sounds really great. So everything seems cool. So we go to select a model here. The models will populate here. And there is also a way for this tool is really cool. You can actually configure, if you had multiple vLLMs with multiple models, like one model per vLLM service, you can absolutely integrate that here. But we're going to select this, and we're going to say, show me a code snippet of a sticky header in JavaScript. Or you can really say anything. This is just one of the default, and so you can say boom, and so that's pretty cool, right? We got a lot of nice formatting, a pretty good answer, and I'm really pretty happy with this. I think there's even some text, some support to read this aloud. I'm not necessarily going to go into all of this, but this is I really like this user interface. Certainly like it a lot more than the Chat GPT interface. And so I think it's definitely for a lot of your users, and it's pretty, if you use some of these smaller models, it can still be pretty fast, a lot faster than, sometimes some of the other managed services. But yeah, so it's so this is pretty cool. You now have the tools to go out and, give your team an open source chat UI for less than, $500 a month. Which is probably cheaper than enterprise Chat GPT at $40 a user per month. And you're in full control of this. You have all the data. You can run your own backups. Nobody else is going to get into this. You have your privacy. You have control over the service. You're not dependent on somebody, on somebody else, screwing with something that's critical to your business. So I really like this, and I hope that like this is exciting for whoever's listening to that, watching this to see, like, hey, you don't need to wait to replace Chat GPT. You can do it today. But great. And so for those of you who might be developers, though, you're probably thinking like that's cool and all, but like, you may be doing a lot of agent stuff, and you're like, well, I want to be able to, how does agent stuff work? And for that, so to do an agent stuff, we're going to go back to our repo and we're going to copy and paste the agent one. So I'm going to close this. This is how you close a lease. You click the little 3 dot button, click close. We're going to pay some gas fee to do that. Not too bad. And again, like, I think like the break even for that Chat GPT, enterprise versus this is about like 10 users. So if you have more than 10 users on a chat service, you can, I think you can save money. It might be a little bit higher for the larger models. So, but let's go to vLLM, and now we're going to go to the Crew notebook deployment. And on this page, there's also like a small snippet for how to use this with Langchain. So Langchain, there's a couple of ways to do this in Langchain. There's an OpenAI compatible API that's like generic, and I think there's even this vLLM specific interface here. So you're going to have to like your service internally is referenced by vLLM. We got port 8000 v1, our model name, our password, and then we're good, and that should be good to go. We're going to go do the Crew notebook. I like Crew for agents sometimes over. There's pros and cons to using Crew. And here's a notebook that you can look at. We'll open it in a second. There's pros and cons to using Crew. Crew is a Crew AI is an agent, is kind of a streamlined agent flow. It's builds on a lot of things in Langchain, but it's kind of built more to like make it's a little bit less syntax involved in it. So it's kind of a more minimalistic framework. It's focused on kind of like multiple agents, but them working in kind of like a linear task of task of different like sequential processes. And so I found it's definitely, can sometimes be a little bit faster to write in than something like Langchain or I also like LangGraph. But again, let's copy and paste here, go through. We say, okay, we closed our lease here. Let's make a new lease, and we'll call it make a new notebook lease. So go here. We call this vLLM notebook. So again, same sort of ideas applied, except now we have our Jupyter app. This is going to be running on a classic Jupyter notebook, not the Jupyter Lab. I'm just doing that here today because I find it a little bit more convenient, but shouldn't be a big deal if you did want to swap that out. The main difference is I've copied that notebook into the container, into this like custom container, just so that way if you want to demo it on your own, you can pretty easily. Again, let's go like 10. Again, it's still that same AWQ vLLM or AWQ Wizard LM2. Okay, so we're going to go transaction pending. Let's get some bids. And so let's see. Let's go get some bids here. And let's see. We go through. Okay, so again, I think we're going to go 4090 again. I think this would probably fit on the A6000, and sometimes if you don't remember this exact tag, it's good to always go like double check before you hit like accept bid, just to make sure that like you have that the model like fits in the VRAM. There's also a couple of those tools that I list in the blog post that you can use like to figure out whether a specific model is compatible. In terms of like, is it big enough to fit into them? It's mostly a question of like, can it fit inside the VRAM with enough buffer for like a longer context length or some other specific settings you may have. But okay, cool. vLLM notebook. We're just waiting for it. Okay. This looks cool. And this went a little bit faster because this is like the same provider that we use. So, it's a little bit faster, but okay, cool. Now, there is one thing that we need to do before we go click this link. So we can click this link, continue. And we go back here to logs. We can see here is we need to get our token for logging into this, and we'll go copy and paste, Control C here. And we'll go to our Jupyter notebook and go password or token, login. Cool. So cool. So yeah, so you should see this page, and now we go to our vLLM crew notebook. We go, okay, this is exciting, so we have some instructions here. So the first thing that we're going to have to do is we're going to have to install our dependencies here. And we should just be able to run this straight down, but we'll need to wait for Crew and some of these other tools to get installed. And so the main thing that we're installing here is Crew and some of the agent tools. So if you've seen some of these examples of agents, giving the agent the ability to use the console or do a search or, scrape a web page, read some documentation. These are all like super important things for agents to do usually. And so in this case, we're installing the DuckDuckGo search tool, and we're also installing the generic like Crew AI tools. So for example, this will take a little bit of time, should be done. Okay, we're done. Great. So we're ready to move on to the next step. We don't see any errors, successfully installed. Cool. So this next step is pretty important because it's like we have to get these in what are the environment variables correctly. We're using an OpenAI compatible standard, and that means we have to have this, which is our key that was specified there in our deployment. We have our base, like this is kind of like the internal service URL. And we have our OpenAI model name here. Now, I will note, if we are using this outside, like I have like a local Jupyter notebook running, or I have or it's like we're using this outside of Akash, like maybe for some development purposes, then I need to, rather than use this top one, I need to use the bottom one, right, that has the Akash provider, Akash provider port forwarding, and it'll usually end in /v1 for the port that's exposed for this. So I'll have to go back and say like, okay, what is my, when we look at this, what is the URL here? When we go look at that, and usually in this case, I believe it's just pub, and I don't even know if it has I don't think this example has a port. It sometimes varies a little bit. We'd copy this and go vLLM, /v, copy paste that /v1. So it would look something like this, I believe. No. If we were outside, we'd want to use something that looks like this. I believe it would be something like that. And so again, okay, cool. So for our example, I was thinking like, what's a fun example to do? And I said like, well, a lot of us have been looking at how to generate different pieces of code, configuration files. We've seen like, if you haven't read about Devin or Darwin or some of these different Open Devin, we've seen these like developer agent tools that have come out that are kind of cool, and we've seen a lot of these across a wide range of areas. So what I said is like, gosh, for me, what I've kind of seen, sometimes people get stuck a little bit, but it's not really, but like for learning how to use Akash deployments, the Akash deployment is a little bit different from Docker Compose and a little bit different from Kubernetes. And so wouldn't it be nice if we could use an AI agent to take our DevOps YAMLs and convert them between file formats? Or better yet, wouldn't it be cool if I just said, hey, go get me like a MongoDB or this database or that database, and have it do all the research and just come back and give me what to plug into Akash, right? Because that would make like my life like easier when I'm running things on Akash. And instead of having to think, maybe about this, maybe I can just kind of, proofread it. And so so this has been, so that way, we don't have to worry about converting between different DevOps, YAML formats across different clouds and different tools. And so great. So what we're going to do is we're going to do that, and the the way crew works is we have to define agents, tasks, and or agents and tasks. And we also have to give those agents different tools. And so the tools that we're going to use today is we're going to use a website search tool, and we're going to use the DuckDuckGo search tool, and we're going to give that example to the agent. Now, as if you're not familiar with agents, like one of the things that people have kind of like found that's kind of a funny kind of quirk or like feature maybe of LLMs is that if you tell LLMs to pretend that there's somebody who's like really good at math, for example, like Spock, if you tell an LLM that pretend that it's Spock, a lot of times its ability to solve like analytical math problems increases. So for this, for the crew framework, like we want to have like a role. In this case, we're going to call it like principal engineer and project manager. And then we give it like a backstory. We say like it's a FANG developer, project manager, etc. And we say the goal to plan and research how to build an application in detail. So we've kind of filled out like our role, goal, backstory. We're going to make it verbose so we can see what's going on a little bit. When you have this is just going to use one agent here. There's also multi-agent and kind of multi-step ones. We actually got this to work in one step, so I didn't have to use crew as much as I would have liked. But we didn't have to do like a super advanced example of crew here to make this work. And so again, this research, this is a task. We're going to use DDent just to kind of like help handle some of our crazy formatting that might have happened. And we say our task is to research how to create an Akash deployment for MongoDB by reading in the docs at akashnetwork./docs and the GitHub repo, our community GitHub repo, and we give it an example here of what a Akash YAML should look like. Our expected output, we say an Akash YAML for MongoDB. And remember, it's not a Kubernetes deployment. So we got our agent. Cool. We should be ready to kick off the crew. Let's go kick off. Yeah. So I hope this has been helpful and informative today. And and if you have any questions on this, on the GitHub repo, we have some, and on the blog, we actually have some instructions on how to troubleshoot. And if you do have an issue, you can just go follow our troubleshoot instructions, and say like, okay, here's all the things that you need to check. And we also have some tools with, can it run this VRAM calculator? Are also interested. If you have questions, feel free to reach out to me, Logan at Thumper AI. Or if you have any other questions or you're interested, or if you do have problems and you followed all those troubleshooting issues, create an issue on the Awesome Akash repo, and and we'll see if I can we can fix what's not working for it.